Hello and welcome to Machine Learning Making Big Data Work for the Enterprise webinar. I'm Serge Haziev, a head of Intelligent Enterprise at SoftServe, the group which combines advanced technology practices such as big data, data science, IoT, and architecture assessment. It's my pleasure to share with you today some of the recipes in big data and machine learning that can help get more value out of data. Today with me, my colleague Yuri Milovanov.
Yeah, hello everyone. I'm a data science practice lead at SoftServe, where my goal is to help our clients bring innovation into their business, leverage data, and solve complex problems using state-of-the-art AI and machine learning techniques. My background primarily is computer science and scalable machine learning.
Today, during this webinar, we will try to answer frequent and at the same time important questions to any business that seeks to incorporate big data and machine learning into a business strategy. Such questions like how to get the maximum value out of data, what big data and machine learning can do for our business, how to pick the most promising business use cases, how to start machine learning project. We will use notion of big data analytics maturity model to discover companies' unrealized potential in adoption of big data. We'll show examples of machine learning business use cases and illuminate 3 best practices which are very helpful from our experience when starting any machine learning project. There is no doubt that many advanced technology companies have secured compelling competitive advantages thanks to big data. For the last few years, its adoption has moved significantly from visionaries to pragmatists. So today it's difficult to find any enterprise organization that isn't investing in storing, processing, and extracting value from their growing data. However, once companies have become capable of collecting and processing massive data, the question then becomes, how can I get the maximum value out of it? Every company is at a different point in its big data journey. So maximizing its business value means moving big data adoption to the next stage. Although there is no a single standard or metric to measure a company's current state, the concept of maturity models is a simplified but efficient way to assess unrealized potential. This graphic illustrates the big data analytics maturity model, which characterizes the path of an organization from its beginning stage data to wisdom, which serves as both as pinnacle and a limitless destination in terms of its business possibilities. This pyramid is an adaptation of the data, information, knowledge, wisdom hierarchy, which is one of the fundamental and widely recognized concepts regarding the data value chain. We use this model since it's easy to understand and its graphical illustration speaks for itself. Now, let's connect the pyramid levels to the business needs of a modern enterprise. What does it mean if an organization is at the data level? Usually it means that the organization has paperless but heavy manual processes and a wide variety of data, from documents and transactional records to media files, machine-generated logs, and sensor data. Data might have been collected for decades from different sources and stored in a data warehouse or in a raw format, but the analysis of that data is underdeveloped. In this case, the organization's teams dedicate a great deal of resources to extracting factual information in a not automated fashion, typically builds reports in Microsoft Excel. It's obvious but worth stating, being on this level means an organization's data processes are holding it back from unlocking its potential, both in operational efficiency and in its ability to innovate new products or services. Information. When data is being collected, it should be processed to be useful and answer who, what, where, and when questions. This is a descriptive state of information, which is often characterized in the form of online reports, dashboards, and self-service capabilities that retrieve information of interest without requesting the support of IT or other departments. From a technology perspective, typically this means an organization has a business intelligence platform that provides access to corporate data. Although this is a significant step in maturity from the data stage, and many organizations can be found at this level, a set of questions still remain unanswered for business users. How, why, and what if? Inside, this level is more complex to explain than the data and information levels of the maturity model, as it moves closer to a manifestation of human mind. For the sake of conciseness, we'll define it as taking advantage of actionable information that conveys understanding, accumulated learning, and expertise. In other words, this level increases an individual's capacity to take effective action. Technologically speaking, it includes the synthesis of multiple sources of information and the ability to uncover hidden patterns and correlations. There are several elements in an enterprise architecture landscape that enable actionable decision-making at this level, including a data lake that collects a wide variety of data from structured, semi-structured, and unstructured data sources, and a data processing pipeline that transforms that raw data into ready-to-consume holistic representations. Organizations that have achieved this level of data maturity usually boast significant improvements to operational efficiency and increased revenue from products or services. What could be better? An acceleration of decision-making, which is the next level. Speed. This level refers to an organization's speed of decision-making, supported by a solid foundation of insight or actionable information. This level generates numerous possibilities by making real-time access to information a competitive advantage. Data streaming, mobile computing, and IoT technologies make these advantages possible from a technology perspective. Greater speed can lead to increased productivity and additional revenue sources. It can also support the optimization of processes that can dynamically adapt themselves to environments that are constantly changing due to factors like market conditions or even weather. Today, many industry visionaries are investing heavily to get to this level. In fact, many might still consider the speed level the ultimate goal, not realizing what is possible when a company moves beyond speed to what we call wisdom. Some may argue that this is a rather elusive concept and has more to do with human intuition, understanding, interpretation, and actions than it does with enterprise systems or technology. In our definition, wisdom is the highest level of the data value chain, the state where digital solutions can achieve superhuman or even superhuman performance when solving difficult tasks intractable for traditional computing techniques. These tasks often imply complex situations that are characterized by ambiguity, uncertainty, and conflicting evidence. This is exactly the goal of cognitive computing, which is in its turn is based on machine learning techniques that mimic the way the human brain works. One of the latest techniques, deep learning, in just 3 years enabled more than what has been done within the preceding 25 years. This is a simplified example of an enterprise big data architecture at the wisdom level. On top of this picture, you may notice two groups of users of this AI-based solution: augmented intelligence and intelligent automation. The main difference between them is that augmented intelligence scenarios help people make decisions through personal devices like mobile, smartwatch, or laptop. And intelligent automation does not require human interaction at all. The system talks to industry robots, cars, or legacy software applications by mimicking human. The latter scenario is called also robotics process automation. What is the most important for any business is staying competitive and not falling victim to disruption or displacement. That being said, it's crucial to look at big data and machine learning in particular not as a technology challenge to be solved by an organization's IT department, but as a business leadership opportunity, meaning that the business strategy should incorporate machine learning to get maximum value out of data and to use it as a powerful vehicle of digital transformation. Many organizations have difficulties at this stage selecting business use cases that will bring the most business value and start technology implementations. Indeed, the variety of possibilities and potential use cases of machine learning is overwhelming. That's why we often hear questions: what can big data and machine learning do for our business? What are examples of successful business use cases in our industry? Although every business is unique in many respects, most business use cases can be derived from the universal monetary drivers, such as business growth and business operations. Business growth drivers can be split to new revenue creation and existing revenue increase, and business operations drivers to productivity improvements or cost optimization and risk reduction, which is minimization of losses. Now, let me turn to Yuri to provide real-life examples of business use cases and machine learning methods that can help generate more revenue or optimize costs.
Thanks, George. That was very insightful. But before getting into the actual use cases, let me first briefly introduce one of the most important trade-offs which arises at the very first stages of almost any machine learning project. This is a choice between shallow and deep learning techniques. Although deep learning is a really hot topic nowadays, and it seems that it's capable of solving almost any problem one can imagine, still there are many use cases where traditional, so-called shallow algorithms are much more appropriate. Let's briefly describe the main advantages and disadvantages of those two approaches to make this picture a bit more clear. So why is deep learning so popular? First of all, those methods are theoretically unlimited in terms of the complexity of problems they are able to solve. Basically, the main limitation is just the amount of data available for training. The reason behind it is that deep learning models usually consist of a number of hierarchically composed layers, where each layer aims to solve its own complexity level of the problem. For instance, modern deep learning models for computer vision may contain thousands of layers which help achieve almost human level of image recognition. At the same time, these models require a massive amount of data in order to get that deep. The golden rule of deep learning states that the more data you have, the more layers you can afford. While traditional machine learning methods are not able to provide that level of accuracy, they usually outperform deep learning methods when the amount of data is small or complexity of problem is relatively low. Another important advantage of deep learning models is that they are able to work on raw, unstructured data, such as images or text, which minimizes the need of subject domain expertise, let's say in linguistics, that is required for building complex solutions. On the other hand, training of deep learning models is highly computationally expensive and requires expensive hardware such as GPUs. Although shallow machine learning methods are usually much easier to train, it might be too simple for applying them to the raw data and require extracting expert-defined features from the data such as part of speech or word importance for text. It implies large efforts on feature engineering for each particular type of data. And last but not least disadvantage of deep learning methods that I would like to highlight here is they usually act as black boxes that solve the problem. It's almost impossible to trace back the logic they follow, which makes it really hard to debug them and, what is more important, interpret the results they provide. That refers to the fact that we still do not know how our brain solves complex problems. At the same time, many traditional machine learning methods come from statistics where human-friendly interpretation is usually much more important than the accuracy of the result. The bottom line, selection between shallow and deep learning techniques is mostly based on complexity of the problem, desired accuracy level, and effort that business is ready to dedicate to solving the problem. Now, when we have a comprehensive picture of different drivers that may affect the choice of business use case, let's consider a few examples of such cases. The following table shows some of the cross-domain use cases from a series of projects that we successfully delivered at SoftServe. Let's imagine that business wants to increase an existing revenue stream by optimizing the price of a product. You would probably consider using the following input information, such as product features, demand for this product, or some business constraints that you want to apply to its price. The output of such model would be the optimal price range for this product defined for any given market segment. The traditional machine learning toolbox provides many different ways to approach this problem, such as time series or clustering analysis. But if your competitors do the same, you would probably consider using deep learning methods in order to differentiate on more precise price predictions. Or let's say you want to reduce your operational risk by applying predictive maintenance on company's equipment. That would require collecting a lot of both structured and unstructured data from sensors in order to monitor and predict the likelihood that a given part or detail will fail in the near future. As those are supposed to be rare events by design, you would need your model to be highly accurate in order not to miss the failures and minimize false positive predictions. The fact that you also deal with unstructured data, such as images, would probably convince you to choose deep learning as the main approach to solve this problem. The next example I would like to describe in more detail. This use case presents the idea of developing an AI-driven chatbot that is able to recognize the topic of the chat conversation to maintain a nearly real-time content feed of relevant articles. Those might be news, tweets, or articles from the corporate knowledge base. What kind of business value can that bring? Say you lead an R&D department where you usually deal with highly uncertain projects and your team has to constantly make important business decisions based on the recent outcomes. You need to keep your team always up to date on the recent technological news, which is usually done by manually monitoring and analyzing a massive amount of different data sources. At the same time, most of the important project-related conversations happen in chat channels. In fact, in digital transformation era, this setting may be relevant to almost any business domain. The biggest challenge in developing such solution is to derive deep enough topic understanding in order to compare it on the data from conceptually different types of data sources. Importantly, that had been almost impossible before deep learning methods were invented. This task is not easy even for human experts. It requires a lot of domain knowledge in corporations such as linguistics. Moreover, the topic is usually abstract and doesn't have a single clear definition. Now, let's try to consider more specific examples from retail domain. Imagine you work in e-commerce and you want to increase your conversion rate by providing your users with personalized recommendations on the products they might be interested in. Toward this, you would probably consider using customer profile and purchase history as well as some product-specific features. As a result, you would like to get the likelihood that the customer will buy a given product. Deep learning methods have been proven to be successful for such use cases and are usually used as an extension to collaborative filtering concept. Nevertheless, traditional machine learning methods are able to provide a good baseline and are quite often used to mitigate so-called cold start problem when not much data is available. And here is a good example which is particularly relevant for offline retailers. It addresses the issue that typical retail sales data is spread across many business dimensions. Offline retailers usually have different types of stores in various locations, many lines of business, and a huge amount of products and product categories. That makes it really challenging to use traditional BI and analytics tools to analyze sales trends and anomalies in all possible business dimensions and their intersections. Automation of this analytics might provide a huge business value to different business stakeholders. They might want to detect significant drops in sales or compare sales performance to some expected value. Given that sales data is usually structured, moreover, stakeholders might need to have a good business interpretation of the results. Traditional machine learning methods are considered to be much more appropriate for this use case.
And now, let's review best practices, which can be helpful for any machine learning project. Ideation workshop is the first important exercise to prioritize business use cases through ideation of potential business opportunities. The ideation workshop includes both business and technology stakeholders, along with big data and machine learning experts, to generate the use cases and to estimate their preliminary business value and ease of implementation. The prioritization method shown below is based on the best combination of these two factors and can serve as a roadmap for further execution. Multidisciplinary team. When business use cases are defined, the project scope and complexity often require the involvement of a team of professionals with different skill sets. It would be a fallacy to wait for the superhero data scientist to come along. Modern business and technology challenges, in order to be solved successfully, require tight cooperation of multiple disciplines. Data science, big data engineering, experience design, and subject matter expertise are those competencies that form a project core team. Design thinking, and in particular the design sprint process, have set up an interdisciplinary collaboration and align the team towards a common target.
Finally, it's worth mentioning that almost every machine learning project is more research-driven than most software engineering projects developed with traditional computation techniques. Business use cases are based on hypotheses rather than facts, so they must be validated through experiments and tests to make them real. In data science, such experiments are performed with help of throwaway prototypes, also known as proof of concepts, using highly iterative and agile cycles. For this purpose, data scientists use a set of tools which noticeably reduce a POC cycle to a few weeks or even days. Once the hypothesis is tested and the model accuracy is satisfactory, the research phase can be considered as done and use cases validation complete.
Now, let's summarize what we have covered in this webinar. So, what are the key takeaways? Maturity model, basically 5 levels from data to wisdom, help assess unrealized potential of big data analytics in companies. Business use cases should be driven by business strategy and backed up by machine learning methods, shallow or deep, or sometimes their combination. Ideation workshop is a great way to kick off an initiative around using machine learning. It allows to facilitate and prioritize business use cases. Starting with multidisciplinary team is much better than waiting for a superhero data scientist to solve modern business and technology challenges. Rapid prototyping is an excellent way to receive a quick feedback on hypotheses through experiments. And as a final note, once business leadership is ready for creative and breakthrough projects, anything is possible. Even the most radical ideas get implementation with latest bleeding-edge technologies. Perhaps this is a beauty of the digital era we live in, to make the wonders of science fiction into the realities of our lives. We are looking forward to hearing your feedback. Should you have questions or comments, please don't hesitate to send them to webinar@softserveinc.com. Thank you for your time and attention. Bye-bye.
Bye.